Hello everyone. This will be a smaller video on the nomenclature of cycloalkanes. So cycloalkanes are named exactly the same way. Count the number of carbon atoms. So in this case, let's do the first one. 1, 2, 3, 4, 5, 6. So we got 6 carbon atoms. So each of those corners is a carbon atoms. So if I have to draw the structure, it should look like this. C, 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 C. And then every carbon atom should have how many bonds? 4, right? So I'm gonna add hydrogen, H, H. So everyone should have 4 hydrogen. So make sure everybody has 4. So that's H, 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 H. So this is a alkane, but this alkane is cyclic, so that's called a cycloalkane. So that's why it's called cycloalkane. So in this one, first one, how many carbon atoms? 6 carbon atom. So 6 carbon atom is hexane, hex, and then ane, because all of them are single bond. And is there any substituents? No substituents, nothing on the first one, but because it's cyclic, so that's gonna be its parent name, cyclohexane. That's the name. Okay, on the next one, the parent name is exactly the same because it's cyclic, 6 carbon atoms. So what happened was one of the hydrogen, so if you look at here, CH2, CH2, C, CH2, 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 and okay, so I'm just drawing the hydrogen on this particular one. So we had H and H. One of the hydrogen is gone. Instead, it has now a chlorine, right? So that either you write like this, CHCl, or you write like this, the line angle structures. Okay, so one of the hydrogen is replaced by chlorine. So what should we name this? So the parent ring is cyclohexane because it's cyclic and it has 6 carbon atoms, cyclohexane. But what is the substituent? So this is parent. And what is the substituent in this case? Substituent is chloro. Chloro. So it's called chlorocyclohexane. Okay, we don't need to add number in this particular example because it's always the substituent is number 1, and since it's a cyclic, it doesn't matter where you put the number. So it's always gonna be 1 chloro. So we don't write that number because there is no beginning in the circle, right? So it's you should always gonna be put the smallest number, so which is always gonna be 1, so you don't need to put number. But when you get to this example, you have to put number. So let me explain why. So let's start again doing this. What is the parent name? Parent is cyclohexane. Okay, that's the parent. So we got 2 substituent now. One substituent is chlorine, chloro. Another substituent is 1 carbon atom right there. So 1 carbon atom is, what is it? 1 carbon atom. 1 carbon atom is methyl. Okay, so what should be the name? Who should come first? Chloro is alphabetically first, so it's gonna be chloro. The next one is methyl, and then cyclohexane. Okay. Okay, now we're gonna add number. So in this case, the alphabetically that's come first should get the first number because there is no beginning and ending, right? So the one that's come alphabetically first is gonna get the first number. So let's call this 1. So this is gonna be 1. Now you can go clockwise or anti-clockwise. So let's do anti-clockwise. So clockwise and anti-clockwise. So first one is clockwise and next one is anti-clock. So the way we pick our starting point is the one that comes alphabetically first. All right, so that's our 1. Then we're gonna do clockwise. So if we do clockwise, 2, 3, 4, 5, 6. So which two number have our substituent 1 and 5? So if we go 1 and 5. Okay, let's do anti-clockwise. So the anti-clockwise, so chlorine is going to be 1 because that's alphabetically first. So 2, 3, 4, 5, and 6. All right, so which two number we get now? 1 and 3. So obviously 1 is same on both of the occasions, but which one is the smaller? 1 and 3. So that's how we're going to number. We're going to number anti-clockwise, not this one. So this is the correct number. So let's do it. So it's going to be 1 chloro, 3 methyl. We're going to write the cyclohexane right after it because it's a one-word term. And that's it. Pretty simple. Okay, maybe I'll do one last example on this one. How we going to go from name to structure. So let's say we do another one. We do 1 bromo, 2 ethyl, cyclopentane. All right, so let's do individual. First, you want to draw the parent. So parent is cyclopentane. So pentane, pent means how many? 5. Pent is 5 carbon atoms. So let's draw the parent first. All right, so we got, now you can number them any way you want. Let's call it 1, 2, 3, 4, 5. Because you are the parent, you can name them any way you want. You can go clockwise, anti-clockwise, it doesn't really matter. But as long as you put the correct locations, the substituent, that's all matter. Okay, substituent. So what's the substituent? Bromo, right? Bromo. And what is the bromo substituent is Br. And what is the locations? Location is carbon atom 1. So let's put bromo there. Then substituent 2 was ethyl. Ethyl is how many carbon atom? 2 carbon atom. And where is the locations? Location is 2. So it's at the locations 2. So on the locations 2, we're gonna add 2 carbon atom. So this is carbon atom 1 and this is carbon atom 2. Each corner is a carbon atom. So again, if you are not comfortable with the line angle, you can always go back to the actual expanded structure. So I could have done, it's just a lot of work, but you'll get it right. So this is, in this method, you will never be wrong. You will never be wrong. Okay, so we're gonna number them 1, 2, 3, 4, 5 because it's pentane. Okay, position 1 is bromo, so I'm gonna delete one of the hydrogen and put bromo. Remember, you cannot have 5 bonds around carbon atoms, so always have 4. So if you're adding something, you have to remove a hydrogens. And the position 2, you're gonna have a 2 carbon atom chain. So it's H, 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 and H. Okay, that's how you build the structures from the name. All right, let's stop here.